Gadget UK here again. As you can see, this time we're looking at a Sega Mega CD 2, you know, the Model 2 Mark II. It's very dirty. Look at the muck around there, and if we eject the tray here, look how dirty it is in here as well. It's absolutely filthy. So yeah, it's going to need a really good clean up. It's probably a sign that it's well worn. So, you know, this might need a new laser. There are a number of common things that can happen with these. They've got little ICPs, you know, integrated circuit protector fuse type little things that are either soldered on one side of the board or the other. There might be more than one. One of those could have gone if we're super lucky. You know, someone could have tried to plug this in or unplug it when the power was on or something like that, and that could have blown the fuse. The mechanism could have jammed up a little bit or something, you know, that could have caused a fuse to blow as well. And of course it could be the caps. Now we don't know whether anyone's been in this, but on first inspection we've got a screw missing there, there and there. That makes me think someone has been in this and maybe swapped the drive out, so could have a faulty motherboard and a faulty drive. Anyway, we'll soon find out. I'm going to go connect this up. What do we need for this? You've got your AC power comes in here. Interestingly, it says AC adapter. It's not. They've had 9 volts, 9 to 12 volts DC. It says there, look, DC 10 volt, 1.2 amp. You've got to use a specific adapter. Anyway, I've got hopefully enough power supplies to connect this up. But I'll plug in a Model 2 Megadrive, power it up, and just see what's happening. So I'll plug the Megadrive in first. You can see we've got to pull this little flap off here. So if we just press upwards a little bit, pull it out. And you can see it's got the little red protector sleeve on there, so pull it off. Yeah, it should just slide then. If you put it down like that, it should slide into place like that. There we go. So I've got both the power supplies connected and switched on, and if I power it on we get the LED, but then nothing else on the screen. So, okay, so I think the next thing to do is to tear it to bits. Let's get the lid off and have a look inside. So I've got it sat on a soft surface here just so that we don't scratch the top of it any worse than it already is. I mean, it's really dirty, it looks scratched up and stuff, but you know what, it should clean up quite nicely if we can get it working. So that's all those screws out. I'm not sure how this comes apart now. There we go. Yeah, so the lid just lifts off. Well, that's a positive side, because these mounts here where I could see there were no screws on the inside, those are just for these. So, I mean the drive. So, I mean, the first thing I would do with this is just do that. You can freewheel it, so that's not jammed. That is probably not the cause of whatever's failed on here. It's going to be a fuse, isn't it? So we'll get all of the screws that we can see from the top side of the PCB here, you know, that are just holding this shield and the motherboard in place. And we'll see if we can find a blown fuse, because I'm suspecting that's perhaps what this is. But it does look like no one's been in this. I'm quite pleased about this. Looks like a genuine fault here, because all the cable ties are in place, and it just looks like no one has attempted to fix this. So it kind of improves our odds, hopefully, of being able to repair it. I mean, there could be something wrong with the main board here. I hope we haven't got like leaked caps or something that's caused lots of corrosion. My first time inside this particular one, so I am not sure how you get this shielding off here. Does it just come up? Yeah, it's kind of like got these little metal clips here, look, just blocking it a little bit. I think I've got all the screws out. I'm not sure how to get it over here. Can you see this? I think what's going on here, yeah, you're not going to be able to see this very well, but what's going on here is these metal clips seem to be restricting it somehow. It's that one there, look. It's like catching. There's one on each side that just kind of, there we go, sticking, causing it to get stuck. Hang on. So there we go. So I think this is one of the earlier ones. It's got the 7474 modification here. Where's the fuse? There's the fuse. So let's just test that. So nothing's caught my eye straight away with regards to caps. The caps look pretty good on this actually. I don't see any corrosion or anything like that. If we just test this fuse, yeah, look, the fuse is blown. open circuit. If I touch the probes together, we get a short. On here, nothing. Can't be that simple, surely. I think maybe, you know, I could be wrong here, I'm speculating, but there might be a way you can blow this. If you stuck the wrong power connector in here, that might be why these blow. You know, a bit like PC engines, you stick an AC adapter in or a DC with the wrong polarity, and maybe this diode here is reverse polarity protection, poof, fuse blows, you know. It could be that simple. That might be why this is such a common fault on these, because I would imagine in normal operation it'd be rare for that to fail. It really would. Yeah, it's looking immaculate to me, that board. I mean, it just needs a bit of a clean. It's a bit dusty, but I think what we'll do in the first instance, I'll just bridge this and we'll try it. So before I bridge that, I'm just going to use a bit of wire, and I will replace it in a minute. But you know what? We can test it, you know, with just bridging it. But the checks I will do is check that diode across there, because I'm pretty sure that diode is going to be. There you go. Look, one side of that is connected there. So that diode is used for reverse polarity protection, I think. So that diode's okay. And it might be an idea just to show you that on the meter rather than just rely on the beep. But you can see there, it's forward switching as it should do. And if I switch the probes around the other way, nothing. That's correct. The other thing you might want to do when you're doing something like this is test some ground. Let's just test either side from, you know, the heatsink here that's grounded to either side of the fuse. And anywhere else that you think is a ground or a negative on the board, just to make sure you don't have a supply short there. We don't. And then the other obvious thing is you could check, you know, the DC input here to make sure there's nothing shorted on the input side. But I'm comfortable with that. I think that's going to be alright. We'll just bridge it with a piece of wire, and then if that works, I'll clean it all up, replace it with something that's rated appropriately. I'm not sure what size it is, 1.5 amp or something like that perhaps. Might not be able to get the exact same package, but I'm sure I can find something that will be suitable. So there are many ways to crack a nut. What you could do is use a croc clip on there, and then try and clip on the other side. But yeah, I'm just going to strip the end off this white piece of kynar here. Just bend it over and just simply solder to each of the points there, and clean it up afterwards when I replace it with a proper fuse. The other thing you might then want to do, if you've got a bench power supply, you know, check the polarity of the DC input coming in here. Set your bench power supply to the right voltage, maybe give it a volt or so less. You know, so instead of 10 volts, feed 9 volts in there or something. Start with that. Set your power supply to current limited to maybe, I don't know, start with half an amp or an amp. And just see what happens. There's nothing really wrong with bridging this. I wouldn't bridge fuses where you've got higher voltages, you know, like in a power supply, switch mode power supply. Never bridge a fuse in one of those. When you're dealing with low voltages like this, it's going to be, you know, either 9 or 10 volts going across this, or it's going to be the output of the regulated side. But I don't think it is. I think it's probably the unregulated input goes through a fuse. That's what I think. I'm kind of too far away from the mains outlet here for the iron, so I'm kind of stretched right up here. And it doesn't matter if we just get a ridiculous amount of solder just onto there, just for now, as long as I don't bridge anything. That's the main thing, not to bridge anything. And obviously the best thing to do here is to take the board out. But you know what, I want a quick test. If I'm going to spend any time on this, I'd rather just see if this is the initial problem. If it is, if it works, great, then I'll invest more time taking it to bits and cleaning it. I mean, it's a bit of a mute point anyway, because you know what I'm like. I'll fix it no matter what. Even if this isn't the fuse, I will continue to dig until I work out what is the cause. So there we go, that's that bridged. Test with continuity again. There we go. So I'll loosely put the lid back on, and let's go and try it again. So power all connected up, let's switch it on and see what happens. No magic smoke. Oh yes. There we go, that was a quick fix, wasn't it? One of my shortest videos, I think. Let's look for the disc. Let's get a disc and try a disc on it. So one issue we might have here is the disc being in the wrong region. I think some of these images I've got here I have changed actually. This one might have been changed to boot. No, it's not. It's playing as an audio disc, isn't it?
This compact disc is for use on Mega CD or Sega CD only.
Thank you. I've got an original disc here. This one's it's one of those combined ones. It's got Columns, Golden Axe, Revenge of Shinobi, Super Monaco and Streets of Rage. Rage, not Range. And I think it's the cartridge version of the game, I'm not sure. But it'll just be interesting to see if that works. Let's hit start. See what happens with that. Well, it's working, isn't it? I think the laser's alright on this one. It's hard to believe, really, just that fuse. Picked up a bargain with this one. Yeah, nice choice of music, Sega. Select and press start button. Yeah, I think that's working. I think you'd be pretty disappointed if you got this on CD and then found it's just the cartridge versions, you know, sold as a compilation, because that's what I think it is. Yeah, that is. Sweet. See if I can get my Final Fight working on this, because the CD version of that is fantastic. Oh yes.
Metro City, a well-known crime capital, has been ruled by violence.
Just skip the intro, see if we can start it. When I first put this disc in, it didn't detect anything, and then I just opened and closed it, and then it was alright. So, well, yeah, it might just need a clean and service and stuff, you know. Sweet. So now we know it works, I'll wash the lid, we'll put this in the sink, soak it with some soap and water, get a scrubbing brush into all these little gaps and the recessed bits and stuff, give that a really nice clean. We'll get the board out of here in a sec. I'll undo the remaining screws, which I think is just these two probably. We'll check this battery, it's probably going to need replacement. Obviously we need to deal with this fuse, you wouldn't want to leave a wire there, although technically it will work. And we'll just inspect and clean up and stuff. We'll perhaps lubricate the drive as well, get some lubrication onto these gears here, clean up the laser lens, but it's working flawlessly. And a final thing I might do while I'm here, we'll have a look to see if there's any more fuses on this anywhere, but we'll measure the RF level on the scope as well and just see what this is set to at the moment. We'll perhaps have a look at what laser this uses as well, because it's always useful to know that in case you need to swap the laser out on one of these. So we'll just get those two screws out of there. That should mean the motherboard should be free, I think. Yeah, you can see it's wobbling up and down here. So we need to carefully disconnect these. I mean, the way I do this, and it's not really technically the safest way, is often to just pull the whole lot of the wires, but you can pull them out, you know, you can pull them out and break them off if you're not careful. But if you take your time and just wobble a little bit as you do that, you can see we've managed that without any issue. This one might be a bit more difficult. I don't like the look of these wires here. Let's carefully. Yeah, there we go. So that's all three of those disconnected. The board then just comes out, look. It's looking pristine. It's looking absolutely pristine. I don't see any issues with that whatsoever. At this point in time I wouldn't even bother recapping this either. But technically you could do to extend its life and stuff, but you know what, the caps look really good on here. It's interesting, this factory mod here, you know, look at the length of that exposed wire there, and look at that one there, that offshoot. I'll probably cut that little extra bit off, it shouldn't really be left like that. And they've used a bit of glue here to secure it and stuff, and similar thing here, you know, a bit of glue in various places, some of it over the top of the pins on that chip there. Sometimes this glue can sort of become conductive with age, or certain types of that glue can. Got a bit of it here as well, just holding that PCB down, and obviously a bit on the top of that chip holding it down. So while we're here, we'll look at the chips. You can see the BIOS there. You could do a region-free BIOS model like I did on a previous Mega CD video there. You know, I put my own larger BIOS in there and had it switchable, and had some LEDs and things to indicate, or I used the existing LEDs actually at the front of the Mega CD1 to indicate what region it's in and stuff. You could do that. So you've got your 68,000 12 megahertz here, so this has got another 68,000 CPU. So, you know, you're kind of doubling up on your 68,000s, but this one runs at 12 megahertz as opposed to the whatever the Megadrive one is. Is it 7 point something or 8? I forget. It's going to vary between region probably, you know, as the clock frequency gets divided down to get your correct video frequency and stuff. So you've got a large ASIC here. This is going to have the PCM stuff, the scaling stuff, and all of the arbitration and all that. I would think, you know, the backbone of the system. This is what makes a Mega CD primarily. It's also worth mentioning, if you don't want a Mega CD but you want to play Mega CD games, you can get the Mega SD from the Terra Onion team. It's a cartridge that has some FPGAs, CPLDs, MCUs and stuff that replicates all of this in a cartridge. So as well as being able to play games on it like you do with the Everdrive, you can also play CD games as well. It replicates the CD hardware functionality in a cartridge. So yeah, I'll post a link down below to that. I haven't had a chance to get one of those yet. It's a bit expensive, and with me losing my job, it's not something I can afford just now, but I might get a chance to have a look at the Mega SD in a future video. So the other things you've got on here, you've got some RAM down here. This might be for the CD side of things. You've got a couple of Sony chips here, factor 3 or so, or 4. This is going to be the CD chipset here. You know, you'll have an RF amp, an MCU, something for controlling the servos and things. I don't know what else, you know, a DSP. So yeah, and I think that's kind of like this strip here. This is the CD stuff. And again, I think you've got what looks like a RAM or something down here. Might not be, it might be a video code of that. Yeah, I'm not sure what that is. It's a Sony CXA 1081. I'll stick a comment up there to what that is. And then you've got more RAM here, look, that's RAM. That's an audio DAC, I think. That's a Sanyo chip there, an LC7883. Can't see what that one is under there because it's obviously blocked. And then some like what look like discrete logic and stuff around here, perhaps, I don't know. More RAM here, look. It's near the battery. I'm inclined to think that that might be save RAM or something. You've got some sort of voltage regulator or switching regulator or something back here. I can't see it at all. I just see it numbered on the board, IC301, and it's, you know, pins 1, 2, 3. So it's probably going to be 7805, I would think. That might not be. So there are lots of test points on the PCB here, but nothing that says anything, you know, in relation to RF. But I can scope them anyway. As soon as we see the eye pattern, you know, and just check a few of them. As soon as we find one that looks like the eye pattern, we know we found the RF signal. And obviously these little variable resistors here, you wouldn't want to touch unless you've made a note of the resistance and things before you start. And you really need to be monitoring specific test points in order to see the change from each of these. There's not very many actually, there's only these 3. I was expecting 4 or 5, but yeah, there's only 3. Anyway, we'll deal with that fuse next, I think, because I don't see anything else I need to do on here apart from just maybe wipe with a cotton bud. So to get the fuse off, we'll just carefully heat this leg here. This is the fuse. See if we can bend it just slightly. It's not going to move obviously until it reaches temperature. There we go. And we'll just add a little bit of solder onto it and then use the solder sucker here. Yeah, it's not wanting to come off. I think what I might do is just pull it through. I might just pull it through the other side, just heat with some solder here, let it heat up and then just pull it through. You might need to use pliers to pull it through, otherwise you could burn your hands. In fact, I'm burning my hands now. But you could just, you know, get a pair of needle nose pliers like this and then just pull it off. There we go, there's our fuse with our wire. Going to block the holes and get the extra bits of solder off in a minute. So inspecting the fuse there, it looks like it's marked 2.5 amp. So just have a go at cleaning it up in the sink. There we go, it's had a quick wash. We now need to just dry it off and wipe it down, get into any little corners that the scrubbing brush didn't get into, etc. But it's looking fantastic actually. So the lid has pretty much dried off. You can see it's pretty scratched, but we'll get the plastic cleaner onto this afterwards. Got some fuses here. They're only 1.5 amp, the Pico fuses here. The one that was on there was 2.5 amp. So I'm taking a risk, it might blow straight away, but you know what? I'm going to just give it a go with a 1.5. I suspect the only time this is going to blow is if you connect the wrong power supply up, probably. So hopefully you can see the meter there, just measuring the battery contacts here. So bear in mind this has only had power for a minute or two while I tested, 2.4 volts there. So I think that the charge capability of that is going to be okay. I think that battery is going to be alright, because the fuse has blown on this, I think, a long time in the past. And I think that the battery level's just diminished, you know, down to about 2 volts-ish, and then we've just boosted it a little bit just from a minute or two of testing there. So the next thing I'm going to do is just use the desolder station there to unblock the holes, and we'll fit a new Pico fuse. These contacts are absorbing a fair bit of heat, if I'm honest. There we go, that's one. Yeah, that one's not unblocking, is it? One thing I would say is, you know, give it time for the heat to pass through, but also give time to your equipment to heat up as well. It's only been switched on a few minutes, this, so despite the fact it says it's at the right temperature on the screen, you know, on the display there, it might not be. And the other thing you can try is from the other side as well. You can always just clean up with a bit of IPA and a cotton bud afterwards. So there's a massive trace here leading to that pad, so it's no wonder it's taking time to desolder. There we go, can you see, unblocked. So I bent the leg over there, just feed the legs through the holes. There we go, there's our Pico fuse. And just over the other side, you could always just bend the legs out a little bit on each side, like that. A bit like they were originally, just hold it in place so that we can then just solder the connections. Again, leave it long enough to flow through to the other side properly. Now the Pico fuse I've put in there is just over half the capacity of the original, so it might blow instantly. I've ordered some of the correct 2.5 amp size fuses, but those are going to take a week or two to get here. So my hope is that that probably will work. Actually, an underrating a fuse, if it works, it's not a bad thing, because the worst that can happen is the fuse pops again. If it doesn't pop, it's kind of safer in many ways, you know. It might be more prone to failure again, but it will certainly save the system if you know, too much current is drawn. Anyway, I might just give that a try now. I think I'll clean up the contacts. I'll clean up first with a bit of IPA on both sides, and then just go try it again. Often with these things, Pico fuse like that, you'll find it's overrated. You know, it probably draws maybe an amp, maybe less than an amp, 0.8, 0.9 of an amp. Someone's decided to put a 2.5 amp fuse in there just to protect it, but under normal operation it probably doesn't go over an amp. I mean, there's different ways you could test that. I could just remove the fuse, put the probes across there, put it in current mode on the meter and test it that way, but it means balancing the Mega CD and trying to, you know, probe those points at the same time. It's not the easiest thing to do, but you could do that to work out accurately how much current is drawing. But the fact it's working with that 1.5 amp fuse just goes to show that you could use 1.5 amp fuse if you wanted to. And you know what, a smaller fuse, you know, a lower current fuse, in many ways is safer than you know, going to the recommended, what was fitted originally, 2.5 amp. It's pretty clean, but you know what, it's not going to do any harm just going over the general area of the board like this, just collect any dust. I mean, there's hardly anything on this. The inside's pretty clean actually. It was just the outside that was a bit grubby. I mean, it's a bit dirty, can you see that? You know, you're bound to get some dirt off. So I've given it a gentle clean. I cut off that little bit of extended wire that was on there. I'm going to trim back that cable tie, because you know what, it doesn't need to be crazy long like that inside the case. One thing you might want to do is just move that like that, and then press it down over there. Just try and hold those out of the way when you stick the metal part back on, you know, the top shielding piece there. We're going to be coming back into this to probe around, try and find the RF test pad later anyway. But we're kind of done with the inside now. I've dusted out. There's a few bits of dust in the corners and things there. I can get those out in a sec. But I think the next thing I'm going to do is get a bit of Molycott onto the gears and things here. And clean the laser lens, I think. So in order to get the plastic hood off here, you put a screwdriver into the point down there, just push inwards a little bit. Can you see this part here's come out? And there's one over here. You do the same thing, just press inwards a little bit. And I think that's starting to come off. There's another one here, is there? Yeah, one there, look. And then the whole thing just hinges off at the back, like that. It's worth doing that because you can now get to the gears and things. It kind of looks like the Neo Geo setup, that actually. It kind of reminds me of that. Or I might be thinking of the CD32, I'm not sure. It looks very similar, but we can get, I mean, there's some grease on there, but we'll put some more on there in a sec. But we can get all this dust off here because there's quite a lot of dust on this mechanism, look. It's all around this rubber thing at the back here as well, lots of fluff. But if we just collect all of that off there, there seems to be a fair bit of grease actually on the actual chassis here where it shouldn't be. I don't know how it's got so oily, this. Maybe someone's been in this in the past, I don't know. I mean, that bit there should be greased because the plastic of the underneath of the carriage just rubs on that, but we can get some more on that in a sec. Bit of this Dow Corning Molycott EM30L. Someone's bound to ask me which one it is because they always get asked. It's EM30L. And we'll just get a little bit onto here, and then when we slide the carriage up, it should start to smear up there. Stick a bit more up here. Careful not to press too hard on these because when you reach the end, the extreme there, it won't go any further. That's when you'll break teeth off if you're not careful. So we've got a little bit of it extra there where it just doesn't need to be. We could perhaps redistribute some of it down this end. You don't need a lot on there, to be fair. Reaching the end now. I'm going to get it all over my fingers doing this, but you know what, it's not the end of the world. And we'll do it on the same, on that one there. If you rotate the cotton bud around, you'll find it sort of rubs off and distributes that way. And again, I've shown this stuff before. You know, you can just put the cotton bud on top and it gets rid of the excess off the edge. Got to watch you don't get any fibres and things wrapped up around the gears and things, or you know, in the teeth. But this is the way I always do it. Just get a little bit on there. You can see, you know, there's a little bit of grease actually got onto there as well. Let's just do the same on that. Get a fresh cotton bud and just wipe off the excess on the top. Do the same up here. Careful not to touch the lens. You know, I'm being super careful not to touch the lens here. Just trying to get the excess off there. So those are all pretty greased up. Look, got a little bit on the top there. Look, let's just get that off. I'll clean obviously underneath the plastic hood here. Just make sure you've not got any dust inside that bit. But then just get a bit of IPA on the cotton bud here and just gently. You can see that fluff there. It's just come off with that. Gently touch the lens here. Try and move around in a gentle circular motion. Use the dry end to just mop it up. Also just give the plastic part here a bit of a wipe as well, just in case any dust has landed on that at any point, because it'll end up just working its way back onto the lens. Anyway, that's that bit done, and then try to hinge this back into position. You get it in the right place, it should hinge like that, and then you can just, you know, bend inwards all these bits on the sides here until they clip back in and hook on. Yeah, there we go, that's it, it's back on. So I left it powered on overnight actually. Obviously I didn't leave the TV on, and I left it just on the CD audio screen, you know, just powered up overnight. The idea being, well, to test it obviously for a prolonged period of time, and it still works fine, just rebooted it, no worries. But also to check the battery. I'm just going to go and measure that battery now to see if it's measuring around 3 volts.
A fierce battle with Dark Dragon ensued.
That was a good test for the Megadrive as well actually, because the Megadrive is pretty warm. It's not something I thought about. but it's a cold room, this, really cold, so there was not much chance of it overheating. But as I say, it wasn't just about testing the reliability over a period of hours, but to measure the voltage on the battery here. Yeah, you can see it's a bit low, 2.66 volts there. So the battery does need replacing. So I've got a spare battery here. It needs cleaning up. This was on something at some point in the past. I can't quite remember what. I think I had it on one of the A500 memory expansions, and then ultimately I swapped it out for a button cell holder, you know, where you can just stick a CR2 or 32 in there. I'm not sure why I did that. Maybe I thought it would be better used in somewhere like this, where internally, you know, rather than something that's easily changeable. So I'll get the battery off. I'll start by just adding a bit of solder. I mean, these solder points here look awful, actually. But that's probably just the flux that's been left on from when it was fitted. But you never know, it might have leaked a little bit. I mean, they don't tend to leak, these types of batteries, to be fair. What does happen is they just, you know, as this one is doing, stop charging. So I tried using the desolder pump, that didn't work. And then I just pulled it through. But you know what happened? This tab just came straight off the battery. You know, it would have been spot welded there, you know, heat. They use, like, I think is it arc welding or something like that they do. You know, it's just like an intense bit of heat that just welds it to the surface there, but it just came off with a little bit of prizing. So I mean, I don't think that would have been the problem. The battery's on its way out, but I was able to use the desolder pump there, as you can see, to unblock the two holes there. This one, yeah, a big problem, because obviously it's connected to this huge area here. So I think what I'm going to do is the same technique I've shown you on other videos. I need to get this the right way around, so the top side here with the print is the positive. That wants to go to one of those two there, that's the positive. And the negative is this one down here, and as you can see, the profile is just right. So while I'm waiting for the desolder station to heat up, because I'm just going to use that just to unblock the final hole there, just thought to show you this battery. Once it's out of circuit, look at this, nothing. There's 0.041 of a volt, and I've got the contacts on there, so the voltage we were probably reading the cap that's across that part of the circuit, perhaps. Either that, or this just discharged super quick after removing the battery. Now I do have a new soldering iron, thanks to Dermot Sweeney. I haven't opened it yet. I'll do a separate unboxing video of that soon. It's amazing, the generosity. I can't thank him enough. There we go, finally. But you saw just how difficult that was, hopefully, that I had to use a fair bit of heat for a fair bit of time. Just see if we can carefully push that through. Yeah, there we go. Yeah, it's kind of misaligned if you look at it. You know, it's not in the exact place where it should be. But we're not bothered about that. We just want to get it on there. So if we just carefully flip that over. I might need to order another battery yet, because we don't know how reliable this battery is going to be. It's been sat around for a period of time in my component drawer there, and the voltage was very low on it. So finally we'll just clean off all that mucky flux there with some IPA and a cotton bud. So I've left it powered up for about an hour or something. I've checked on it a few times, switch it off. I'll just disconnect it, plug its power, and just lift the lid off. So there's a few different things I'll point out here. So if you measure the voltage like this, you can see 2.8 volts roughly and going down. Sorry, 2.28 volts and going down. Now that's a good sign, but that's what I saw before. You know, so that could lead you to think, oh, the battery's alright, but why is it going down so quickly? There's a cap on there in parallel, I think. I don't know where it is, but if we just switch the meter into, put this positive probe here, into the current one here, so these effectively now act as a short, and if we put it into current DC, like that, when we put over these contacts here, we're going to short the battery out, just temporarily, like that, just for a second, because what that will do is the cap that's across it, it will discharge it, and if we put it back on volts DC and measure again, we'll get the accurate voltage, which should be climbing if anything. Hang on. Yeah, so we should get an accurate voltage now, and if anything it'll be climbing slightly. Can you see that? It's going up. So that's the correct voltage of the battery as things stand, and obviously it's climbing. The reason it's climbing, it's a bit like capacitors, you know, when you short them out they can swing back the other way. And obviously, you know, you short the battery out at that point in time, so the battery has the same sort of effect, where it drops by a certain amount. As soon as you remove the short, then starts to gradually climb back up to its correct rating. So, you know, that's for about an hour, from pretty much 0 volts for an hour, it's gone up to about 1.3 volts. So I think the next thing we'll do is just clean up the lid. I'll leave this on charge while I'm cleaning up the lid, and we'll check it again. We're about 1.3-ish volts there, aren't we? So obviously we cleaned this in the sink earlier, but what we'll do now is just get a bit of Maguire's Plastex onto here, and we'll just see if we can improve the surface of this somewhat. You're not going to be able to remove these scratches here because they're kind of like permanent, you know, physical, quite deep scratches in the plastic, but if we just give this a bit of a polish, it might come up a little bit better. Wipe around like this to get the remainder of it off. Use a toothbrush to get into the corners, because, you know, you'll get little bits of the polish in the corners there. But I mean, if you just look at the bit I've done here, look how much shinier this is now. It just looks so much better, but you'll still be able to see the scratches on it, obviously. Yeah, so we haven't got rid of the scratches there, but it just looks a lot cleaner. So we'll do the same thing on here, just gently. We want to try and avoid the white print here, because that might come off, but you can see, you know, it's a little bit scuffed and stuff here. So we'll just see how we can improve that, if at all. And it's kind of like a textured plastic, this, so I want to be really gentle with this, actually, not put much pressure on. And as I say, when it comes to bits like this, just go over it really super gentle like that. Don't put any friction or rub around that area. This bit here, I think, will come up really shiny as a result of this polish. It seems to be like a piece of plastic that's like clipped into it. You know, it's made of a different plastic than the plastic that's next to it. I can't see any screw mounts or anything holding that in. It just looks like it's kind of pressure fitted into place. So again, be super careful over that white bit there, just really gently when you just go over that like that. You know, no more than that really. You just want a one pass kind of thing. And we'll give this bit a go up here. As I say, we can use the toothbrush here just to get into all these little bits here, because you will get bits of white polish in there that you don't want to stay. So around the back here you can see we've got some paint marks or something here, you know, pretty nasty scuffs. This is where you need to use a bit more friction when you get little marks like that. So again, a little bit of plastic polish on there. But can you see that one that's just come off, look? Yeah, you can get all these little marks off here and it should look pretty much good as new. There's a bit of paint or something right in that gap there, look. So there's a few hairs and stuff on this, but the white marks have gone off the back. Still looks a little bit faded here, there's bits of dust on it. But yeah, same thing I always show, some silicone back to black. Get some of this on here. You could use, I don't know, Pledge or something with beeswax, you know, your polish. But I mean, just look at the difference that makes. I mean, there's a little white mark there, and you know, there's some scratches here that are just not going to go away. But hopefully you can see how much better that looks now. You know, once you get the bits of dust and hairs and things off it, it's yeah, it looks almost good as new. So I left it on for another hour and then just did the same thing there. You can see it's over 2 volts now. So that is working. I'm comfortable that that's okay. I'll just reassemble it, I think. So I'm going to check the RF level now. You can see I'm just using the calibration signal here, 0.2 volts. Scope's on times 10. It needs to be, otherwise it will interfere with the read. So you can see I've just calibrated this, so we've got one block here representing the 0.2 volts peak to peak of the test signal. I've got it set to AC coupling because it's an RF signal. I've got to somehow take the lid off. I'm going to have to hold the lid switch here at the back, I think. Put the disc on there. Let's just do that. There'll be a magnetic piece that I need to take from the underside of here and clip that on. Now these things usually just like kind of like twist off or clip off. It looks like it's kind of clipped on there. So this thing was a pain to unclip. There are 3 clips around the inside lid. You've got to sort of prise them at the same time as lifting these 2 pieces off here, and then eventually it'll come off. But that should mean at least that'll secure that there now. So the next thing I need to work out is how I'm going to plug this in here and get it to stay in position. To be honest, it might just sit there. Let's just try that. It's sagging down a bit. I don't like trying this, but we'll give it a go. Yeah, it's working, but it's not sensing the lid shut. I think we need to do something with this here, maybe. So it took me a while to find it, and I actually found it using the service manual. I'll show you a page of the service manual, just pop it up briefly. But you can see, yeah, IC402 is here, and it's pin 2. So pin 1 starts down here, it's the second pin along, and there is a test pad that's marked TP-RF. Well, I couldn't see that. So now we know that, I'll stick a disc in, press A to go into the CD player, and I'll start playing an audio track. And we'll probe pin 2. Yeah, that's pin 2. I need to adjust the time base, I think. Right, it's on track 3. If we now just move that right down to the bottom, we can count how many blocks we've got. 1, 2, 3, 3/4, almost 4, I would say. If you go from the bottom of this peak here to the top of that one there, and it stops now, and it's going to the next track. The short tracks, those, yeah, you can see it's almost 4 blocks. So we've got almost 800 millivolts there. But bear in mind, that's with a burnt disc. I'm going to put a pressed disc in, and we'll try the same thing with that. So there's the difference with a pressed disc. You can see it's considerably more. So if we count what we've got now, 1, 2, 3, 4, 5, and almost a half. I would say you've got 1.1-ish volts there. So that's what you want to aim for with a pressed original disc, just over the 1 volt mark. The nearer you get to 1 volt, the longer the laser is going to last. You could probably reduce that a little bit by adjusting the laser voltage on the actual optical pickup itself, you know, on the laser unit. And you can see that's how I was tricking the thing to think that the door was closed. Let's see if we can just pull this piece of tape off. It's just obviously 2 metal strips, and they just press next to each other like that. So if you tape them together, that will trick it into thinking the door's closed. And just for completeness, because I did say we'd have a look at the lasers, so you can see it's a KSS210A. That's a Sony unit, I think. I think they all start with KSS. So I'm not sure what other models use that particular laser. Some of these Model 2s have a Samsung pickup, I think. The carriage and everything might be different. I honestly don't know. I would assume it's probably not. It's probably got the same chassis and everything here. It's probably just the lasers can vary a little bit. So one final thing before we assemble here, you can just about see the pot there. It's kind of pointing a little bit to the left there. I hope that's focusing. So if someone's messed with yours, you know how to set it. So you can see this one here again is just pointing ever so slightly to the right hand side. That one there's almost straight down with a tiny little hint of a twist to the left, although I don't know actually, it looks like the package might be a bit bent, so the pot position is looking straight, but yeah, if you look at it proportional to the metal part, it's a little bit to the left hand side at the bottom, and this one's sort of pointing to this corner here. Those are the only 3 adjustments you can make on here, as far, well, 4 if you include the one on laser that you can make on this. So this would have also had a grounding plate that goes underneath the Megadrive and joins to here to give a good electrical join, because you can see, you might be able to see some ground contacts there inside. So it's not got those, and it's not got the little plastic extender that normally goes on the side here that allows a Model 1 Megadrive to fit on there properly. So all reassembled, working perfectly with the Megadrive I fixed in a previous video. I'll stick a link up there. I do hope you found the video interesting. Please like, share and subscribe, and I'll catch you in the next video.